Hello all, welcome to Code Hub. Today let us solve the lead codes daily challenge, and the problem is add one row to tree. So given the root of the binary tree and two integers val and depth, add a row of nodes with value val at the given depth. Note that the root node is at depth 1. Okay, and the adding rule is given the integer depth for each not null tree node cur at the depth minus 1, create two tree nodes with value val as cur's left subtree root and right subtree root. So cur's original left subtree should be left subtree of the new left subtree root, and similar ways right subtree root. So if depth is 1, that means there is no depth. So depth minus 1 at all. Then create a tree node with value val as the new root of the whole original tree, and the original tree is the new root's left subtree. So this is an edge case. So let us first analyze what is the problem. So this is the given tree and the depth is 2. So at the depth 2, this is depth 1 and this is depth 2. So we should add another row at the depth 2 with the value 1. So 4's left is 1. So 1's left becomes this whole subtree, and 4's right is this 1, and 1's right becomes this whole subtree. That's it. So how can we solve this problem? So hope you understand. Here the depth is 3. So 1 2 3. So in this depth we have to create one row. So that is depth minus 1. Go to this depth. So depth 2's left, we have to create one node by 1, and 1's left is this 3, and 2's right we have to create one node, and one new node's right is this tree. So hope the explanation is clear. So now let us approach this problem. So what is the initial thing that comes to our mind? It is going level wise. So obviously we are going to do a level order traversal using Q, level order traversal using Q. So that is going to be our first step. But how we are going to do? So here the depth is 3. Then I should go till depth to depth minus 1. So first depth, second depth, and I have reached this depth. If I have reached this depth, I will be I will be um, uh, attaching the new node to its left and right, and I will attach their left and right subtrees to their respective new nodes. So this is what we are going to do. So first we have to reach the level depth minus 1, and then create new nodes of left and right and attach the respective subtrees to its left and right. So that's what we are going to do. But how we will be doing this? I'm standing at this particular node, then I will be creating a new node, let's say node 1, or else I will say it as left node. So first I have created this new node. This is the new node for left node with the value this val, and I have created this. So now I will say consider this 2 is my current node. I will name it as cur. So first I should not lose this subtrees value. So what I will do is left node of left is nothing but my cur of left, and then my curve of left becomes my left node. So hope this makes it clear. So I'm not losing this subtree value, and then first I'm restoring it in my left node of left, and then I'm marking the curve of left to be my left node, and I have attached this new value, and similarly I will be making the new right node, the similar stuff here. So these are the two important steps that we are going to do, and that we can see in our code. So but we have to handle some edge cases. What is edge case? They have also mentioned that edge case this as the fourth point. If my depth is 1, then initially I have to create one row. So I can create only one node with the value val. So first I will create that value node, and I will mark this root whole tree as my left of that new node, and then write to be none, and I will return that particular row. So I have to handle that case alone. So hope this is clear. Let us try to code so that you will get more understanding. So for first I will once I come to this position itself, what I will do is first I will check if my depth is 1. If my depth is 1 itself, then what I will say is I will create a new node, tree node star node equal to new tree node of val. So I have created this node. So now my node of left is nothing but my root, and now my root becomes my new node, and finally return this root. If my depth is 1, this is what I'm going to do. This is my edge case. This is my 4th point to be done here. But if my depth is greater than 1, then obviously if my depth is 2, I'm going to stop at this point, depth minus 1, first depth itself. So what I can do is I can have a queue first, the node star. This is my queue's data type queue, and q dot push of root. So I have pushed the root, and initially my depth is I will decrement my depth, because each and every time I'm going to see I have reached my depth minus 1. So I will make my depth to be 0 based indexing, and I will have a condition. I can have a condition as while q not empty. Instead of that, what I will do is I'm going to decrement my depth each and every time till my depth reaches once. So what I will do is, if my depth is greater than or equal to 1, I'm going to go inside this while condition. So I'm going to process the whole level. So I should take the size of the queue first, queue dot size. So now I want to process that particular level. So this condition will be enough for that case. Now I will be processing that particular level. Each in that particular level, how many ever nodes are there, I'm going to process that level nodes. So first I will get the current node. Current is nothing but q dot friend, and I will pop that out. What I have said is, if my depth is 1, then what I will do is, if my depth is equal to 1, I am attaching a new node. So I will just copy paste this new node, copy paste this code here. So here tree node star left node equal to new tree node of val. So here my left node of left becomes my cur of left. What does it mean? Cur of left, even if it is null or even if it is a value that is stored in my left node of left. That is what my problem states. Next, my cur of left becomes my left node. Hope this is clear. Now what I should do is, I have to create similarly a right node. So I will create a right node with the value val, and now I have to point my right node of right to my cur of right, and my cur of right becomes my right node. Okay, these two statements only should be here. I have Okay, now it is clear. So hope this is clear. If my depth is 1, then I have to do this process, or else what I can do is I can have a else part, and in that part I can say if my curr of left is present. If my curr of left is present, I will push that into my queue. Similarly, if my curr of right is present, I will push that into my queue. And each and every level I am going to decrement my depth. And finally I am going to return my root. And that's it. So this should be running fine. Let us try to run the code. Yeah, it gets accepted. Superb, it gets accepted. Let us try to give the other case as well. If my depth is 1, what it should return? It should make a new value, and it should point directly. Superb, it got accepted. Now let us submit the code. So what will be the time complexity of this solution? The time complexity will be order of n. You can see it is going level wise, and yeah, it got accepted. Superb. I hope you like this solution, and let me know in the comments. And I will show the code once again. So I have handled the edge case here if my depth is 1, and I have decremented the depth initially itself because I am handling it as if my depth is reached to 1 only, then only I'm going to do the function. So I do that. So I'm decrementing the depth, and I have pushed the root into my queue. And for when my depth is greater than or equal to 1, I have to come inside, and I have to process that particular level. So I'm taking the particular level size, queue size, and till my size minus minus, I'm going inside this loop, and I'm getting that current node and I'm popping it out. And if my depth is 1, then I have to create that particular left node and right node, and I should not lost the current of left node. So first I'm making that to be pointed by this left node of left, and then curr of left is left node. And similarly I have taken the right node, and the right node of right is becomes the curr of right, and my curr of right becomes my right node. If this is not my depth, then I can push that particular node into my curve of left to my queue and curve of right into my queue. And I hope even if this depth is not greater than or equal to 1, we can say it as this condition itself. If my queue is not empty, I have to perform this particular case. Even this should work fine. Let us try to do it. Yeah, it works fine, so we can submit this code as well. Superb, it gets accepted. Hope this also works fine. So you don't want to get confused why I have used as depth greater than or equal to 1. You can use directly the condition, which is this: while queue is not empty, I'm going inside the slope. And if I reach the depth is 1, then I'm doing this process. So I'm not pushing any node into my queue, so that only the queue is empty in the next level. So hope you like this solution. Let us see in tomorrow's LeetCode daily challenge. Until then, bye.